Have you ever looked up at the sun and thought, it's just a big ball of fire? Perhaps you've considered it merely a distant light source. Well, think again, because the truth is far more astonishing. The sun is a nuclear powerhouse, a time machine, and a cosmic clock that controls everything from Earth's precise orbit around it to the very sunlight that greets you each morning. It's the heart of our solar system. Let's dive into 10 mind-blowing facts about this incredible star, the one that not only keeps us alive, but also dictates the rhythm of our entire planetary neighborhood.
Our sun isn't solid like a planet. Instead, it's a massive sphere of superheated gas, approximately 74% hydrogen, 24% helium, and a tiny sprinkle of heavier elements like carbon, oxygen, neon, and iron, all swirling in a dynamic dance.
Every single second, an astounding 600 million tons of hydrogen undergo nuclear fusion, transforming into helium deep within its core. And the missing 4 million tons of mass? They're converted into pure energy, a colossal output that powers everything we see and feel on Earth, from photosynthesis to the warmth on our skin. At its very core, temperatures soar to an unimaginable 15 million degrees Celsius, a heat so intense that it's hot enough for nuclear fusion to happen continuously, releasing immense amounts of energy. The sun's visible surface, the photosphere, is cooler, around 5,500 degrees Celsius. But here's the weird part. The outer atmosphere, known as the corona, can reach up to 3 million degrees Celsius, making it significantly hotter than the surface itself. Scientists still don't fully understand how this outer layer manages to be hotter than the surface. It's a perplexing phenomenon and remains one of astronomy's greatest and most enduring mysteries, actively researched by solar physicists. The sun makes up an astonishing 99.86% of the solar system's total mass. That means everything else, all the planets, their moons, countless asteroids, and distant comets, collectively share the remaining minuscule 0.14% of the mass. Its massive gravitational pull holds every single planet in its precise orbit, from tiny, innermost Mercury to the distant ice giant Neptune. Basically, the sun is the undisputed boss of our entire solar system, orchestrating its every movement. It takes light just over 8 minutes to travel the vast distance of 150 million kilometers from the sun's surface all the way to Earth, a journey that seems incredibly fast to us. But inside the sun itself, that same light, or photon, can take an astonishingly long time, over 100,000 years, to escape from the incredibly dense core, bouncing randomly through layers of plasma before it finally reaches the surface and bursts into space. So, the sunlight warming your face right now might have started its epic journey from the sun's core long before humans even existed on Earth, carrying ancient energy from deep within the star. The photosphere is the visible layer we see, glowing intensely at about 5,500 degrees Celsius. Above that lies the chromosphere, a reddish layer, and then the expansive corona, which, as mentioned, can reach millions of degrees, creating a complex atmospheric structure. This strange and counterintuitive temperature jump, where the outer atmosphere is hotter than the surface, might be caused by powerful magnetic waves or explosive solar flares blasting energy outward into the corona. We still don't know the full answer to this coronal heating problem. The sun keeps some of its most profound secrets well hidden, challenging scientists to unravel its complex physics. Every second, the sun loses about 4 million tons of its mass as it continuously converts matter into pure energy through nuclear fusion, a process that has been ongoing for billions of years. That's the incredible power of Einstein's famous equation, E=mc², demonstrating that even a small amount of mass can be converted into an enormous, staggering amount of energy, fueling the sun's immense luminosity. Even with this constant and massive loss of mass, don't worry, the sun has an incredibly vast reservoir of hydrogen fuel, enough to last for another 5 billion years, ensuring its continued existence as our life-giving star. Sometimes, the sun gets quite moody and active. It releases powerful solar flares and massive coronal mass ejections. These are giant bursts of charged particles and magnetic fields that erupt from its surface and blast into space. When these energetic solar events hit Earth's magnetic field, they can cause beautiful and mesmerizing auroras, like the northern and southern lights. However, they can also disrupt satellites, interfere with GPS systems, and even cause widespread power grid outages. In 1859, a massive solar storm, famously known as the Carrington Event, was so powerful that it made telegraph wires spark and even catch fire, demonstrating the potential destructive force of these solar phenomena. The sun is made of plasma, a superheated state of matter, so it doesn't rotate uniformly like a solid ball or a planet. Its rotation varies depending on the latitude. At the sun's equator, it completes one full rotation approximately every 25 days. However, as you move closer to the poles, the rotation slows down significantly, taking about 35 days for a full rotation. This uneven rotation, known as differential rotation, twists and tangles the sun's powerful magnetic fields, leading to the formation of dark sunspots and explosive solar eruptions that can blast millions of tons of plasma into space. Our sun is currently 4.6 billion years old, meaning it's approximately halfway through its stable main sequence life, a period where it fuses hydrogen into helium in its core. When it eventually runs out of hydrogen fuel in its core, in about 5 billion years, it'll expand dramatically into a red giant star, growing so large that it will engulf and swallow Mercury and Venus. And there's a strong possibility it might even consume Earth too. Eventually, after its red giant phase, it will shed its outer layers, creating a beautiful, expanding shell of gas and dust known as a planetary nebula, leaving behind a dense, hot remnant called a white dwarf star at its center. This will be a peaceful, beautiful, and gradual end to a blazing, energetic life that sustained our solar system for billions of years, transforming into a cosmic jewel. Without the sun's immense gravitational pull, Earth would not remain in its orbit. Instead, it would shoot off into the cold, dark expanse of space in a straight line at an incredible speed of 30 kilometers per second, lost forever. Every orbit our planet makes, every changing season we experience, and every ocean tide that ebbs and flows, all of these fundamental processes depend entirely on the sun's powerful gravitational pull, a constant, invisible force. It's not just a star in the sky. It's the fundamental anchor of life and stability in our entire solar system, making it truly indispensable for our existence. Yes, the sun actually sings, though not in a way we can hear directly. It produces complex acoustic vibrations deep inside its interior that then ripple and oscillate across its entire surface, creating a subtle, rhythmic pulsation. Astronomers meticulously record and analyze these subtle vibrations to study the sun's internal structure and dynamics, a specialized field of science called helioseismology, which is like using sound waves to peer inside the star. So in a profound and scientific way, the sun is constantly humming a complex song of creation, revealing its inner workings through these acoustic waves, a cosmic symphony playing out across billions of years. The sun gives us light, warmth, and life itself, making our planet habitable. It's been burning brightly for billions of years, sustaining everything we know, and it'll keep shining long after we're gone, a constant in the cosmos. So the next time you feel the gentle warmth of sunlight on your face, take a moment to remember that you're not just feeling warmth, you're feeling the immense, ancient power of a star, a true cosmic marvel.